yeah, I'll talk a little bit about automation and how we apply that to cloud IMS and how that enables us to learn and to enable some of the exciting use cases that are coming beyond that. So we've heard a lot, obviously this week and over the last year or so, about exciting possibilities that are coming as we move into a 5G future, and whether that's the low latency applications, the advanced virtual reality type of things, or just the increased number of connected devices with industrial IoT and huge broadband. There is a lot of possibility here for what we'll be able to do with the network in terms of generating new services. And part of that will drive requirements for slicing, and here both within the 5G next-gen core network, as well as potentially within the data networks. On the right-hand side, there's going to be a requirement in order to satisfy all those different use cases for us to be able to do slicing. There was an example report last year I heard on IoT, an IoT service, that if you compared an IoT service delivered using a multi-slice network compared to just a single slice network, then that could generate over 30% increased revenue over a few years, and at the same time reducing the costs of that service by 40%. So slicing will enable some of these services to be both increasing revenue and to be justifiable. But there's a huge complication involved here because we struggle at the moment often to deploy a single instance of a core, of an IMS core or of an EPC. And here, if we've got to deploy many of them and operate them and change dynamically, that's a huge challenge. And it's one which, there's a lot of complexity that will come with judging how do we deploy 5G, what's our strategy for multi-access edge compute, how do we combine in roaming with all of those requirements. And if we look at that, without the ability to automate the entire of this network, things are going to be hard. And I use an English phrase when I say that there's a danger here that with the excitement of 5G, we are perhaps putting the cart before the horse, and that's going to cause us some problems in terms of actually successfully making the most with 5G. So, if we're heading towards the El Dorado or the Nirvana or our mythical perfect future, then, there might be some problems with the way we are setting about that. And that's something that we can definitely do something about. If we look at the challenges that we are facing, and everybody's talked about this this week, as well as the technology which requires further advancement, there's also, of course, the processes and the change in attitude and skills that people require. And alongside that kind of human aspect of adopting NFV, one of the striking and somewhat shocking examples of where we see problems today is that service providers operating a service see that sometimes over 60% of service outages in their network are a result of a human error. So this is something that's perfectly, this is not a technology problem. This is a human error resulting in service outages. And other people put that number a lot higher. And that's something where automation can really help with reducing those kind of errors and therefore increasing the success of those services. When I talk about automation here, I'm really, we could get stuck in the weeds of different terms, whether it's orchestration, automation, choreography, or anything. I'm really talking here about the full operation of the network. So the lifecycle management, instantiation, healing, upgrade, scaling, as well as all of the configuration of a service, so as well as instantiating VNFCs, how do they gain their service configuration, like protocol timer configuration, peer devices, etc. And talking about validation, so the process by which we roll out configuration changes or updated software throughout the network, how does it get validated? Today we do see sometimes, as a vendor, we can produce a new software release and it'll take, often it'll take a year before anybody even touches it, and then it'll take 6 months of testing within a lab before that's anywhere near production. And at that point, we've lost years, potentially, of opportunity. And then I'm talking about provisioning as well. And provisioning is probably the area where, as an industry, we are most advanced today in terms of integrating services and allowing for operators and possibly end users to do provisioning. But the rest of the network, there's a lot of opportunity there. And if we see here, compared to the capital expenditure, if we can reduce that operation expense, there's a massive opportunity. You're talking 3 to 7 times the expense in terms of operations compared to the capital. And here there's both direct benefits through improving network operations and customer service through automation, but also if that brings increased service stability, improved user experience and reduced customer churn, then there's indirect benefits in terms of operational expense there as well, in terms of sales and marketing for those services. So when I look at how do we adopt a more automation-friendly environment with our technology, and I talk here with this kind of abstract diagram of what the network can look like, with the sample VNF at the bottom right, under the control of a Vim and a virtual network function manager. In this diagram, on the left-hand side is the kind of configuration control for the entire network. And that might be an ETSI NFV orchestrator. It may be a collection of tools that incorporates more software development practice tools, such as Git. So for example, we could, well, in all cases, I think this thing up here will be something which is using version control, and it's using model-based definitions of the network to control everything that goes on in this network. And this is the model that we call infrastructure as code. It's the case, instead of using interactive configuration tools for managing the network, we're using a machine-readable definition file to do model-driven declarative definitions of what the configuration and state of the network should be. And this means a change in the way in which the operator is interacting with their network. That you're no longer going and typing in anything or manually doing operations. Everything can be controlled through a model definition, and the process by which you do that can be to update it in a version control repository and then apply those changes in a very similar way to that which development happens of a software product, with commits and pushing those to different branches to be applied to different parts of the network. So this really will enable us to move towards the true DevOps methodology. It enables us to continue a kind of software development process with continuous integration and continuous development into the network through adopting these kind of models. And the benefits that we can get from that are in 3 areas, I guess, with cost reduction, increased speed, and reduced risk in particular. So if you look at that 60% number I said before, automated methods of procedure can drastically reduce the chance of errors going into the network. So there's a huge saving available there. And at the same time, those automated procedures mean that upgrades and changes can be reduced, and you no longer, or you can condense any of these procedures for operating on the network and reduce the requirement for these long overnight maintenance windows. And that can be fully extended towards continuous integration throughout the day. We don't need to move that far yet, right? There's obviously some kind of reluctance to go too far too quick, but there is huge possibility there. And then in terms of speed, the example at the top right there about testing, it's quite hard to quantify quite what the benefit there is. But if we're able to validate every test automatically using automated tools that are built into that, validation tools built into that config management system, then there's opportunity to just push new things into the network much faster. And that leads to, obviously, the benefits of being first to market with new features, whether that's new software upgrades or just changes to improve the service. So you can see there, I mean, these are attempts here to quantify some of the benefits that we can achieve through a fully automated infrastructure. And one of the dangers is to say, well, okay, we can do all that, and our IT people are doing all of that, but they're using container infrastructures which are far better for achieving these kinds of things today. And I think there's a danger there that we wait too long and don't get stuck in with automating the network as much as possible today. So examples we've got where customers are deploying with virtual machines and are making use of some of those tools of managing the network as infrastructure, as code. There's an example here, this is just a dashboard put together using the open source Grafana tool, but it's demonstrating load in one of our operator customers for our IMS core, and this is showing a network in which there are multiple core sites and many tens of access network sites, all running combined over 2,000 virtual machines, and millions of subscribers. And this network is something which traditionally we might have seen it being very long lead time to produce. But in this case, we're able to turn up sites in less than a day. The entire network can be upgraded in a couple of maintenance windows overnight. And that's something that just wouldn't be possible without adopting these kind of techniques for managing the network as code. And that's all possible today with, this is an example using virtual machines in OpenStack. We recently did some enhancements to our Clearwater core, IMS core product, showing that with virtual machines where it might take 1 or 2 minutes to boot the virtual machine, our latest container deployments can boot within 3 or 4 seconds. There's obviously a drastic improvement that can be resulting from that as you adopt more container models. But that's not necessary. We can achieve a huge amount today with virtual machines. Other things, it's just an area that we're heavily involved with at Metaswitch. We've been doing a lot of work in terms of improving our VNFs and our processes and our deployment methodologies for automation in this NFV environment. There's a white paper here that my colleague Paul did with Telia late last year. If you haven't seen that, it's a really good kind of exposition on the environment and where automation is going. And if anybody's interested, then Metaswitch has got a booth downstairs. Do come and talk to us about how you see automating the network and the possibilities for improving. Where I want to lead from that is to say, if we adopt some of those ideas, and with our IMS core, we think that it's entirely now possible to spin up new instances very trivially within an hour to create new IMS core slices, then we are in a great position to be able to really benefit from the network slicing that will come with 5G networks, including dynamically creating slices as needed when devices attached to the network. And here, I mean, as well as slicing the next-gen core, the data network can be sliced. We can see opportunities, obviously, for different IMS networks within VoLTE and RCS or IoT, as well as different private enterprise LTE. We can have examples where enterprises require push-button order, and they can get their own private LTE network. All of these possibilities will come along with 5G, but they are possible there with the IMS core. And I think that's just where I wanted to highlight that, that there's a real danger that we don't go fast enough with automation. And we said there's the technological side. I think if you select appropriate virtual network functions that are designed for the cloud and designed for automation, then we really need to move on with those people issues, with the skills, with the change in methodology. And I think there we see a lot of spinning around and designing for a perfect future. And I think we're seeing most success, certainly from our own experience, with those operators who are just getting stuck in going into a kind of cycle of doing, using a cloud VNF like ours, evolving, learning from mistakes and what works, what doesn't, and improving. And just going through that cycle is I think, necessary to get us moving. And I think if we do that, if we make those changes, then we can be in a situation with my silly diagram here, where our horse is now firmly back in front of the cart and able to, carry the load of 5G and make that successful. Without that, there's a danger we won't get the benefits that we really need. And with that, there's obviously accelerating innovation, using potentially the resource that we freed up by reducing risk and reducing costs elsewhere. And we can do that through IMS core slicing, through 5G core slicing, and through automating the entire lot using this infrastructure as code model. And with that, that's all I have to say. I can take any questions. Yeah.
So I'm Steve Loudly. So may I ask you, so you are deploying model-based declarative deployment, right? So are you based on which modeling you are talking here? Are you using Yang or Tosca?
So it can be any. I mean, so we've used some examples where using Tosca, in some cases with Yang, but we can support. I mean, this is partly an integration task that will depend on the network that we're deploying into. But really the key thing is that it's model-based. We do find that then it's possible to convert between models. That, this is a machine-achievable task. But certainly providing Tosca templates for orchestration is something we do. Providing Yang definitions is something we do for configuration. So really, I think it's the adoption of a modeling language. It's not so important which.
What about automation? People are talking about automation of assurance.
So, yeah, that question around closed loop and assurance. Yeah, the question was around assurance and the use of closed loop within automation. So I think there's obviously enormous possibilities to introduce that. We can gain a huge amount without needing to do all of that. I think that's one case where it's amazing to see everything that's being done with closed loop systems attempting to ingest alarms or state of the system or monitor and take immediate action. That's fantastic, but there is a danger there of over-engineering that and never getting anywhere with the more simple aspects. So we're working a lot on that, and working with people, but there's no need to wait for a perfect closed-loop system in order to benefit. Any others?
I have a question if nobody else does. I was just thinking about, in terms of starting, and taking action with what's possible now.
Mm.
Do you have a couple of thoughts or examples of things that people could do straight away before an elegant orchestration answer arrives?
So that question was around, what steps can be taken immediately before an amazing orchestration system is available. I think one of the key things is just to realize that a lot that we do today can be automated. So I think it's a case of looking at where is a lot of time being spent manually today, and seeing are there ways of optimizing that. I mean, I used that validation example earlier, but we do see that there's a huge amount that could be automated there in terms of acceptance of changes and new software into a network. And that's a case where we don't need a perfect orchestration system to be able to improve on that. So there are kind of low-hanging fruit things like that where we can make enormous savings immediately. Or more.
Let me ask one question related to the configuration management automation.
Yeah,
specific configurations like timers.
yeah, correct.
So, this is something not trivial to put this in a model or in Tosca, so it's a bit tricky to define a complete configuration of IMS in some Tosca format. At least this is
So it's a case where it's not standardized at all in the same way that we may see for Tosca definitions of VNFs themselves, but it's still possible to come up with a model definition of an IMS core. And I think I'd say the same. We may not have a standardized IMS core definition, but if we can produce a machine-readable model, that at least is a significant improvement on anything else. And so that is possible. Great, thank you.